All right, welcome everybody to another AMS Weatherband webinar. We're thrilled to have Keith Koenig and David from Weatherband here today, or sorry, from WeatherFlow, my apologies, here today to talk about their amazing systems. This is the second in our instrumentation series, and we're looking forward to a couple more installments over the next coming weeks. So thank you all for being here. I'd like to ask you all today if you could put your questions in the Q&A. I see a couple coming in already. So that Q&A box is where we will be looking for questions. David is here to answer those throughout the presentation, and then Keith and David will be ready to answer some more questions at the end of the presentation as well. So we don't have the ability to accommodate raise hand features today. So if you could put those questions in the Q&A, that would be fantastic. So with that housekeeping aside, again, we're so excited to have WeatherFlow here to speak with us today. Keith Koenig is the head of business development for WeatherFlow, and he has been there for about 6 years, I believe, leading operations and expanding their amazing systems so that we all get to enjoy better weather observations and data sharing. So without any further ado, I'll hand it over to you, Keith.
Thank you. First of all, I'd really like to thank Tiernan and Eric and the team at AMS Weatherband for inviting us for this opportunity to be in front of this group. And I'd also like to thank everybody on this webinar who've taken time out of your days to join us. And I think the fact that simply that you're here and you're interested means that you guys are the cutting edge of citizen science. And I'm kind of preaching to the choir, but as our weather changes, our world gets more interesting. The difference in weather patterns are, let's say, atypical of late, that it is more and more important that we have a whole army of folks actually collecting really good data, and we're using that data to make informed decisions. So thank you to everyone on this call for what you do on a daily basis and taking interest in weather. I think we're all in this together. I'm going to share quite a bit about WeatherFlow. We're a company of about almost 50 folks now. We've been around for over 20 years, and we've been working really hard on quite a wealth of systems. And I've been told that I have under 40 minutes to tell you about everything. So it's going to be tricky. I'm going to have to go fast. If I don't cover something that you're curious to know about, my colleague David St. John, who's one of the founders of WeatherFlow and the head of product, will be happy to answer your questions in the Q&A chat. And we can also follow up afterwards. So here we go. Bear with me as I'm going through a lot of information. It's going to be a little bit quick. Let's see here. As I mentioned, we have been around. We've been designing professional weather stations since 1993. WeatherFlow actually has deployed the world's largest professional industrial grade mesonet in the world. We've started out deploying it in really key areas in the coastal North America, and we have many, many stations all over the place. We provide weather data services to folks like NOAA, Department of Defense, US Navy, major insurance companies, and a whole plethora of weather data users. On the poll here, you see one of our founders, Phil Atkinson. Phil's a Harvard electrical engineer and one of the world's foremost experts in deployed weather networks and systems. By having more than 3 decades of experience deploying weather networks out in the field, we have the opportunity to work with most of the professional grade equipment out there. Campbell, RM Young, Luff, Gill, Hydromet, Ott, Maximum, Texas Electronics. We've worked with everything. We've put it to the test, and the networks that we own and operate are really dependent on high reliability, cost-efficient operations. And so our field knowledge has been really instrumental in our journey to get to where we are now. In addition to deploying weather networks, we're also experts in data assimilation and the use of that data in high resolution regional forecast modeling. We actually bring in not only the data from the WeatherFlow networks, but we've spent about 20 years bringing in a curated set of public domain data from a vast disparate sources. We ingest over 1 billion pieces of weather observations on a daily basis. We have systems to curate that data so that it is normalized and useful, so that we can assimilate that into running our own mesoscale numerical weather prediction models. And we've been doing that now for about 20 years. Our team at WeatherFlow, majority of us are degreed meteorologists, but we also have data scientists, software engineers, hardware engineers, and more so, we have a growing team of PhDs in atmospheric science in our Fort Collins office, developing modeled products against the wealth of data that we're bringing in. Let's take a look at weather monitoring. As I said, we have nearly 3 decades experience putting out professional grade networks. What you see here pictured is one of the WeatherFlow professional stations. This one happens to be in Lake Erie outside of Cleveland. We have an agreement with the US Coast Guard to deploy stations in really key locations, such as on navigational aids. And our team of meteorologists actually look at all of the resources in an area and decide what the best place is to site a weather station where we are going to get things like the best wind fetch, representative conditions that aren't otherwise monitored or observed by other networks in place. And then we go out and our team installs these really high-end stations in key locations. We actually got very good at this, and we got a lot of questions about extreme events. And so our team actually developed a hurricane monitoring network, which is widely deployed in the Gulf Coast of North America, all through Florida and all the way up through Maine. These are very specific hurricane-hardened stations designed to withstand the rigors of an onshore hurricane. They are consistently mounted on a cement pole at 10-meter height. They have triple redundant communications. These are the systems that the National Hurricane Center relies on when things get really ugly. The one pictured here is actually in Cameron, Louisiana. This one took a direct hit last year from Hurricane Laura and remained up and reporting the entire time with wind speeds in the low 100s. On our journey, after deploying a pretty vast network of stations like the ones you see here, we got lots and lots of requests for the ability to remotely monitor weather kind of wherever you are. And so we took a little bit of an experiment to see if we could design our own equipment and sell consumer products. And so the weather meter here was developed in about 2014. This is a pretty sophisticated little device that costs under $100. It measures wind, temperature, humidity, and pressure, but it works with a smart home application to assign things like geolocation, timestamps, and instantly publish that both to the WeatherFlow data systems and as well as publish it out to Twitter, Facebook, and anywhere else that you might want to share that weather data from a distinct location where you might be. We find these really pretty useful little devices for things like in-field agricultural monitoring, for guys fighting fire out on the ridge and sending data back to the command center. Even just hobbyists at the beach that want to report the exact conditions of where they are and then have the world able to see those data virtually live. And then after being fairly successful at developing and offering the weather meter, we started taking a longer look at the state of personal weather stations. And we took a look at what was available in both the cost and performance that one might consider a backyard weather station. And we found that there was a lack of kind of modern technology, a lack of modern data systems. They're sort of old and clunky. And so our team collectively decided we were going to build a better mousetrap. And so for the last 5 years or so, we've been fairly active in developing, producing, and selling the Tempest personal weather system. And I'll spend much of the rest of the talk talking about the details of these. But our team is really proud of where we come, and we think they're pretty powerful little devices that are affordable for almost anyone to put out in their backyard, at their business, virtually anywhere. They operate very efficiently, and we try and price them at a cost that gets lots and lots of them out there. So let's talk about Tempest. So we specifically call Tempest a system and not a weather station because there is so much more about the system than just the hardware. And I have lots of slides to talk about that. But first, let's talk about the hardware. So our design spec, after spending all of those decades in the field, we said, no more moving parts. We don't want anything with bearings to rust and things to fall off. And so we wanted to create a solid state device with no moving parts. We challenged our team to say, hey, if this is going to be for the general public, my mom has to be able to set this up in 5 minutes and be instantly online. There's no 40 or 50 page instruction manual. It's not complicated. You pop it out of the box, you follow a few steps on an app, and literally my mom can do it in 5 minutes. All of the data from the system is QC'd by WeatherFlow and our data sciences, which I'll get into a little bit more. We're very confident in the system. In fact, we offer a 2-year full warranty and a 10-year limited warranty. As we look at the device, starting from top to bottom, on the top is a light sensor, which produces data on brightness value, UV index, and solar radiation delivered as watts per square meter. We have a proprietary haptic rain sensor, which I'll get into a little bit more detail in a subsequent slide. A sonic wind sensor, which I'll also get into a little bit more detail. There's a pressure sensor housed in kind of the neck of the device, which reports both station and a normalized sea level pressure. There's a temperature and humidity sensor in this radiation shield. Quick note on the radiation shield, we tested lots and lots of device designs on the radiation shield. And we came up with a design where the passive radiation shield does a pretty good job of deflecting a lot of the solar influence. But being that this is an all-in-one system that actually measures light, so you want to put it out in the sun, and measures wind, you want to put it in a very exposed situation. It was very clear that we needed to account for solar radiation and overheating causing a skew in the temperature. And so we actually developed mathematical formulations and onboard algorithms that look at the temperature, the solar radiation, the wind, and when you actually know the thermal dynamics, you can apply a coefficient and normalize the temperature to account for the influence of solar radiation, giving you a very accurate ambient temperature reading, even though it's in the full sun. As we come down here, the Tempest is self-powered. It has 4 vertically oriented solar panels. They're vertically oriented so that in the winter months when the sun angle and the sun hours are low, you get a more direct influence of solar input. And during the summer, when you have longer days and higher intensity sun, it still has adequate power to power the onboard battery. The onboard battery is actually a special lithium titanate or LTO battery. those of you who are electrical engineers probably realize the inadequacies of lithium-ion batteries, which stop taking charge when it gets below freezing. And so we've worked with our electrical engineering team to have a lithium titanate battery, which works into very, very cold temperatures to keep the device powered with very little solar input for about a month on end. Also down in the bottom, isolated from the sonic transducers, is an onboard lightning sensor. The lightning sensor is a great little device. It does both cloud to cloud and cloud to ground strikes, but we also enhance what the end customer sees by virtue of having a network of sensors. And so if there are lightning strikes detected at a range that's outside of the detection range, say 50 kilometers away, we can backfill the data that you see from other data from the network to give you a more complete picture of the reality around you by virtue that the crowd is smarter than the individual. In addition, this whole sensing device is totally wireless and self-contained so that you can put it in the best location to measure the environmental values as you wish. Let's take a little bit longer look at the sonic anemometer. So those of you that are unfamiliar with sonic anemometers, they are incredible little devices. They are very, very accurate. They, as opposed to your typical spinning cup anemometer, there's no bias from inertia. You can have a very low cut-in speed, as opposed to a spinning anemometer. It takes some minimum velocity of wind to get it even going. A sonic anemometer takes an instantaneous sampling of wind. In our case, a lot of times down to 0.2 miles an hour cut-in speed. Our sonic actually is sampling wind continuously, reporting wind every 3 seconds. We report lull, average, and gust values. Our entire reputation at WeatherFlow is largely based on our expertise in measuring surface winds. And so the Tempest, one of the main product design requirements was the best wind sensor in the world that was both low cost and low power. It is incredible that we can actually produce a sonic anemometer that's both self-powered and wireless, that operates at the accuracy that these operate. How do we know this? Well, our Florida offices are actually in the Innovation Center on the campus of Embry-Riddle Aeronautical University in Daytona Beach, Florida. We are literally 75 yards away from one of the world's premier wind tunnel test facilities. And we test the heck out of these things. And I can tell you in full confidence that the wind accuracy of this sonic is fantastic. Let's talk a little bit about the Tempest haptic rain sensor. So it's based on a fairly well-studied concept. Many of you know the notion of a distrometer. We took that concept and applied a lot of learnings and a lot of additional technology. We call it a haptic rain sensor. Very, very interesting technology. It allows us to report accumulation by the minute, by the hour, by the day, week, month, year. It's unique in that we can send you a rain notification the instant the first raindrops are being felt. It's unique from a tipping bucket sensor in that we can tell you the exact number of minutes of rain in a given day. So we can look back and say, you know what, yesterday, your accumulation might have been 1/10 of an inch, but we know that that 1/10 of an inch came in 187 minutes yesterday, so that you can get those additional pieces of data. So if you're living in Seattle where you say it rained all day, but you only had 1/10 of an inch, you'll know exactly the number of minutes of rain you had in a given day. It's unique in that it also delivers both a value for the rain rate quantitatively and the instantaneous intensity, so qualitative value. Is it drizzling? Is it raining at a medium rate? Or is it actually raining cats and dogs? The haptic rain sensor can tell you that instantaneous. So it has that additional qualitative value of the intensity of rain at any given moment. Those of you that have studied rain like we have know that rain is a tricky science, and that no matter what type of instrument you put out, the nature of rain and the way it falls can be extremely variable, especially as any tipping bucket or the haptic rain sensor here is really point sampling in a 4-inch diameter sampling plate. So to that end, we actually have a technology that we call rain check, where we look at the post-rain event analysis, and we use a 7-factor high-resolution rain footprint model. And what that does is give a much better representation of the neighborhood level rain, what you might expect over an acre or two, as opposed to that 4-inch sampling plate. And at the user's option, we can actually run algorithms that compare the raw data from that 4-inch sampling plate against that neighborhood level. That'll give you a much better, broader perspective on the rain patterns in your neighborhood, in addition to just that 4-inch diameter sampling plate or tipping bucket that you might have out there. And I know there'll be a ton of questions on this, as it's a fairly new technology, so feel free to ask those in the Q&A. Moving on, mounting options. So Tempest is designed with a few different mounting options. This is what we call a pole mount. It's designed to go on your standard 1-inch pipe. So any 1-inch PVC pipe, it'll go right on in seconds. A number of our customers use the galvanized steel fence top rail, commonly found at Lowe's and Home Depot, for about $7. Giving you the option to mount it in any way you see fit. Those of you on this call, I'm sure, realize how important sighting is. Absolutely the number one thing that would really determine how your data ends up. So if you're sighting for wind, making sure that it's away from obstructions. If you're sighting for any other reasons, the Tempest is very, very accurate in measuring the exact conditions in the exact location you put it in. It's also shipped with a flat mount option. So you could literally use a single screw and put it on a fence top post. And also in that flat mount base, there's a really handy 1/4-20 thread mount, which works with quite a wealth of options in the photography world. Tripods and mounts and the like go right into that 1/4-20 mount, giving you a lot of different options to put the Tempest exactly where you want to measure those environmental conditions. This is a map, obviously, of North America. We've been at the deployment of Tempest systems for kind of a short 2 years. We're proud to say that there's over 25,000 reporting devices across North America. There are Tempests all over the world, even though we've only spent our time focused on marketing Tempest in North America. We see devices in Chile, Argentina, Brazil, New Zealand, Tasmania, Russia, all over Europe, etc. And we're just getting started. So, citizen science is alive and well, and the power of the network, because we are actively using data from every Tempest that passes our QC, that as we deploy more and more Tempests out there, our ability to improve the services for all of the users of Tempest grows and grows with the intelligence of the crowd. So we've talked a lot about the hardware, and that's really the easiest thing to talk about because it's there and tangible. I do want to talk about everything beyond the hardware. But first, let's kind of take a look at how all of the data gets flowing, and then I'll talk about what we do with the data. So the Tempest system, as I described, the sensor sits out and is totally wireless, self-contained, We have a proprietary sub-gigahertz radio telemetry. We say that it works to 1,000 feet, even though we have many customers that are getting a really clear line of sight signal out to about 5 kilometers. Our engineering team tested, I think, 27 or 28 different combinations of radios and found really one strong combination that has a great wireless range. Those data packets are sent from the Tempest sensor device into a receiving hub. We deliberately designed the system as 2 different components so that when we want to change out the hub to some future technology, that the sensor device does not become obsolete. And so the Tempest as it is today publishes data in 3 ways. The main way that the hub publishes data is via Wi-Fi. So you plug it in your house, it connects to your home Wi-Fi, and it publishes the data to the WeatherFlow cloud. For those that are operating with no internet, or perhaps you have some local services like local home automation, the hub actually publishes data all the time over a broadcast protocol called UDP, where you can listen to the UDP broadcast and bring that raw data in locally and use it as you wish. The hub also broadcasts over Bluetooth low energy. So if you happen to have no internet and you're near the hub and running the Tempest app, you can see the live data from your sensor device right on your phone. But the most normal way to use it is actually to publish the data to the WeatherFlow cloud, where we do a whole litany of data sciences and curation. Then we use an API to provision what most users are seeing in the Tempest app. And it's this crazy circle here in the WeatherFlow cloud, which is really the secret sauce behind the Tempest system. And it's actually the most difficult to talk about because it's not tangible, it's not hardware, it's not what you're used to, it's fairly atypical, but it's really, really, really important. And I will get into talking about that. So we've spent, as I mentioned, nearly 2 decades working on our data collection, curation, and data sciences so that the data that we collect from a vast array of sources is actually quality controlled, normalized, curated before it is actually put to use. So we go out and we collect all of the data from the Tempest network. We collect data from the WeatherFlow professional network. We collect data from a vast array of other sources. As I mentioned before, we're pulling in over 1 billion pieces of weather observations. And we throw that into a pretty sophisticated system of checks and balances, quality control, neighbor comparisons, and corroboration and regression analysis, et cetera. We do things like we delocalize the observations. So if a wind sensor is at 100 feet versus 10 feet, if things are in a situation where we have additional metadata, we can actually normalize that data, curate it, and make it a useful homogeneous data set, which is actually very fundamental when you're talking about a publicly deployed network of weather stations. You have to have a layer of quality control so that any outlier data, so the 2nd grade teacher that put the temperature sensor on top of a blacktop roof, we need to kick out that data because it's atypical. Or any number of anomalies, our system will actually look at those, flag the data, and not let it through our curation services so that it doesn't get misused in things downstream, like assimilation into forecasts. We can also do things like append additional data into what the end user sees. And so like the example before, if there's things like lightning strikes seen somewhere around you, but your station didn't sense a lightning strike, we can backfill that and give you a broader sense of the data by virtue of having curated data from the network in your area, giving you a much better picture, the best available data, not just the data from your station, but the best available data from a wide range of sources to give you a more complete picture of what's actually going on at your house. So if you look at the top right of this screen, you see a broad catch-all term, useful real-time data. We actually use that curated mass of data as the input for the next slide here. So as the input into our proprietary forecasting system, we take that mass of data, the billion observations from a bunch of disparate sources, curated and normalized. We also look at, I believe we are running operationally 9 different global and mesoscale models. We run that into our own numerical weather prediction model down to 1 kilometer resolution in many areas. So we are very unique. Not many other weather station companies do this, but we have an entire team of PhDs who are running our own high resolution numerical weather prediction models in many areas down to 1 kilometer resolution by virtue of assimilating massive amount of data, many of which nobody else in the world has. From there, we actually run a regional analysis to say, hey, is our fancy 1 kilometer model better than the best models out there in the world for a particular region on a particular day? Are there synoptic conditions that say, you know what, this model is going to outperform our model, or is our model the best? And so we run a decisional analysis on a daily basis, on a regional basis, to figure out what is that fundamental basis of a forecast, what is the best model to put forward. We don't stop there. We then, for every Tempest in the network, we look at the model output using machine learning and pattern recognition, so collectively AI. We compare the data from each Tempest against that best regional model. And we look at it over time. And through that pattern recognition and machine learning, we can fine tune the model output for every location we have a Tempest and post-process that forecast output and improve it dramatically because we have the data from that location. Our data scientists and our PhDs in atmospheric science have been actually scrutinizing the data and looking at the performance of this new AI-based system. And we're somewhat blown away by the improvements we're able to provide over many of the best models in the world. Let me show you what that looks like. Apologies in advance, this is a little bit complicated to take all in, but that center of, in the previous slide, the center regional decision of the cylinder was a decision to say, should we use the WeatherFlow Tempest AI model? Is this the best one we think for this given day in this given region? We make a decisioning choice based on a ton of statistical analysis. And we are finding, this is a slide that looks at 20,000 stations over a week of time for the parameter of temperature. And we decide, should we publish this fancy AI forecast, yes or no? Or should we publish the next best fallback regional forecast? 87% of the time, we publish the Tempest AI forecast, and based on a post-haste comparison to the data, it is absolutely the best model. 8% of the time, 8.8% of the time, we've made a decision that the AI forecast is not the best one to give to the customer. Instead, we present the fallback regional forecast, and it ends up, because of a post-haste comparison of the data, the best available model performance for that given day. So collectively, at 90-something% of the time, based on a post-haste analysis of what actually happened from ground truth, we are able to give the customer the absolute best model in the world for their exact location. The red pinkish squares here are days where we've failed, where we chose to either fall back, so the upper right, the 1%, to fall back to not the Tempest AI model, to the regional model, and it wasn't better. Or we chose to publish the AI model for that particular location, and it wasn't better than the comparable regional model. but we're just getting going, and it gets better with time as we get more pattern recognition and machine learning. And these percentage values are fairly astonishing out of the gates and going to get better and better over time. Again, this is an analysis over 20,000 stations for a week. Let's take a look at one individual station. So what we're looking at here is a comparison above this horizontal line of the Tempest AI forecast versus below the line of that reference regional forecast. And this is a very detailed analysis of one station on the parameter of temperature in a very difficult topographical environment in coastal California. We found that the AI forecast, when compared post-haste to the actual data, dramatically outperformed the best available other forecasts in the world for this region 93.6% of the time. For about 6% of the time, the comparison was fairly statistically insignificant. So the meaningful improvement by going with the reference forecast was not that much different. And about 1.5% of the time, the AI forecast just got it wrong. And so these early results, when looked at in grave detail, so this is from November 2020 to May 2021, is a very, very detailed statistical analysis that gives us absolute confidence in our ability to deliver better forecasts where we have a Tempest device. To that end, we deliver everything to the end user via mobile apps. So in our mobile app, you can see real-time data from your Tempest. You can see 3-second updates of wind, zoomable graphs down to 1-minute resolution of all the data. And to the point of my elaboration on all the forecasts, we are so confident in our ability to deliver the best forecast, better than anyone else in the world, for your exact location. We actually guarantee we can deliver a better forecast for your location when you have the Tempest installed for at least 8 months, so we can have that pattern recognition and machine learning to train our models to really deliver a meaningfully better forecast. So we are very, very different than the average weather app on your phone. We are not repackaging National Weather Service. We are not just doing a pretty up of other publicly available forecasts. These are proprietary forecasts fueled by the data coming from your backyard. Let's take a look at some of the other features. We have a whole array of alerting. We get calls every week. Hey, I just wanted to tell you that I saw a bolt of lightning. I then got an alert on my phone, and then I heard the clap of thunder. It's pretty cool. We hear it from customers all the time. You can set up lightning alerts, rain start alerts, frost warnings, virtually any system of notification and customization. We have quite a range of options via IFTTT. It can literally like ring your telephone, do a whole range of very interesting things with the data coming right off of your Tempest. Also, we give every Tempest owner their own custom web page. So we call it a web app. This can be found at tempestwx.com. This happens to be a station in my backyard, so you can get all of the conditions. As you might imagine, we deliver forecasting, so hourly forecasts and forecasts out 10 days. We pay particular attention to the 0 to 36-hour forecast and providing dramatic improvement in the performance of those forecasts by including your Tempest data in the AI calculation. Also, in the web app and the mobile app, you can see live conditions, you can see 3-second wind values, you can see all the parameters, you can see derived parameters, feels like, delta T, etc. All of those are in there. You can click into any of the values and see a graph of information. You can change the temporal resolution on the graphs from 1 minute to 5 minute, 30 minute, hourly, daily, and monthly. And you can also go into the history and go to any calendar date that you have the Tempest deployed and go back and see all the superlatives, so low, average, high of all of the different parameters. And in a soon to be released version of both our web app and our mobile app, you'll be able to go in and look at collective summary data on a daily, weekly, monthly, and annual basis, which is particularly apropos for things like rain accumulation. So how much rain did we get this week, this month, this year? That's coming very soon in an update to both our web app and our mobile app. And all this is free to the Tempest owner and user. We also provide an open Tempest API that is published on GitHub. Through our API, you can actually get live real-time data, including a feed of the rapid 3-second wind updates. You can see all the historical 1-minute wind data. It also includes the point-specific AI-powered forecasting, and we make it free for personal use. Our intention is to encourage the collective creativity and intelligence of our users to go out and build cool stuff with fundamentally better weather data that's both curated and augmented with forecasting. There's no way our team can go out and build every cool widget you can think of. And so we liberate the data and we liberate the forecasting, et cetera, through the API. And we just love it when people have a very creative and intelligent use of what's resulting from their Tempest in their backyard. We, on a similar note, we are very, very focused on liberating that data and making it useful. There's many integrations already in the field. You can very easily hook up your Tempest to Alexa, to Google Home. I mentioned a bunch of IFTTT formulas. We've got Siri shortcuts. We're working on a Smart Things integration. We have integrations in development with most of the major smart home platforms, and a very robust and active community building drivers and integrations for all kinds of stuff, again, through the open access to our API, creating meaningful decisioning and downstream uses of the Tempest system. Here's just a few quick examples. This is Weather Display, which is a desktop app that use our API and have cool ways of looking at your data through a different lens than our apps. There's a native Home Assistant integration. Home Assistant is, one of a plethora of smart home platforms. There's already an integration built for Tempest, and you just put your WeatherFlow username and password in there, and boom, all of the data can be used in the Home Assistant environment. Here's another popular one. This is for your technically savvy do-it-yourselfers. It's a Pi console display that uses a Raspberry Pi integration and has a lot more detail and complexity using the data coming off of your Tempest and by virtue of the Tempest API. So I know that I raced through a lot of this, but I'm coming to the end here, and I wanted to end with a collective slide here. And we as a company think that weather data just contained for your own use is actually selling it a little bit short. We think that as a society, that we all need to be in the realm of citizen science. We all need to be collecting data, and that data needs to be put in the hands of people making critical decisions. To that end, WeatherFlow is a founding member of the National Mesonet program. If you don't know what it is, Google it. It's a really interesting public-private collaboration between folks like NOAA and private companies like WeatherFlow, where we have an agreement with the National Weather Service to provide our curated set of data for your regional National Weather Service offices to use, and use to the extent for their mandate, which is the protection of life and property. We have the ability to take the collective data set and provide it to regional emergency managers. So your fire departments, your hazmat teams, your folks preparing for extreme weather events can really benefit from a broader data set, as can folks like energy companies trying to predict demand and trying to make efficient use of the limited resources of energy. And last but not least, the climate scientists who are seeing an unprecedented change in our weather patterns, and those municipal policy managers saying, geez, we really need good data to make good decisions. And that starts with all of us now collecting good data and putting it in the hands of those making decisions. And so that I will pause and stop. I would assume there's lots of questions in the chat, and I'm going to stop sharing so I can see some of those questions and answer them verbally.
Thanks so much for that amazing talk, Keith. I just wanted to help catch up on some of the questions. David's been doing an amazing job answering them, but there were a couple themes that kind of emerged. And one was around data collection and kind of looking at the, like, what type of curation that WeatherFlow does for data when it is brought up to the larger network.
Sure.
And
yeah,
whether...
Great question. So it would probably take me about 3 hours, and I would probably invite some of our more intelligent, bigger brained employees to help with the answer. But we run a litany of data sciences, which in very, very generalized terms, we run corroboration analysis that looks at multiple other sources of data and looks at the raw data coming off of the Tempest and says, does it look right? Does it smell right? Is it in line with a vast array of other sources that we can run things like a regression analysis against and determine if there are outliers? And we run it in different ways for different parameters. But there are so many things going on to make sure that only curated quality data gets through and into the assimilation of the models, that if folks have like particular variables they want to know about, we can take that as an aside. But in very general terms, we often have a dozen corroborating ground truth data in the near vicinity, as well as 9+ mesoscale model values. And we can say, wait a minute, there's something going on here, as well as a system of metadata that many of the Tempest users will see in a forthcoming program.
Great, I look forward to learning more about that. In terms of the people accessing their data, there are some companies that do charge for access once it's transmitted to a website.
Yeah, so we are fundamentally a weather data company. When an individual buys a Tempest, they are granted the right to access the data from their individual station in perpetuity. One of the ways we stay in business is the rebroadcast of that data is protected intellectual property, as we've spent 20 years and millions of dollars with all of this data science and fancy stuff. The only way we stay in business is protecting against the rebroadcast of that data, but any individual can access all of that data via their app, via Tempest WX web app, and via the API for their personal use. And let me acknowledge that is without fee. We have commercial customers who we charge fees for those ongoing data services, but not our personal users.
Sure, got it. Makes total sense. Thank you for that. One of the other kind of cluster of questions was around citing your Tempest system. And
so citing is a very interesting topic. I would hazard to guess that we are among the world's leading experts in citing, having deployed the largest private mesonet in the world. It is a great question, and our answer is yes. There are standards from the National Weather Service, et cetera, on citing. A lot of those standards are very difficult to accomplish. The most difficult is a clear, unobstructed wind fetch. To that end, we say, hey, you're a homeowner, you're getting a personal weather station, you measure the weather that you want to measure, and we have very sophisticated systems to analyze the data coming from your system and to understand what is valuable for downstream use in models and what is not. But what you want to measure, put the temps in exactly the location you want to measure. So for example, at my house, because I've worked for WeatherFlow, I have 2 Tempests. I have one on an 8-foot pole on the top of my roof, which is fantastic for wind. But I don't hang out 8 feet off the top of my 2-story roof. And so I have another Tempest down on my pool deck. And oftentimes the pool deck is 8 to 10 degrees warmer and half the amount of wind because it's sheltered by a fence. And I have a radiant heat sink with a cement around my deck, but I want to know how warm it is at my pool. I'm not hanging out on my roof. So our answer is put it where you want to measure.
Great. Yeah, I love the combination that Tempest has of that really personalized weather and then the ability to extrapolate it out to make sense within a bigger picture. That's really exciting. One question did come in about hurricanes in particular and what kind of winds the Tempest can handle. If it's, on example, a galvanized pipe above the roof line.
Yeah, so we get asked this all the time. And let's just say that your mounting will probably fail before your Tempest will exceed its ability to measure. And so if you're getting blasted with 132-mile-per-hour winds, it probably really doesn't have anything to do with the Tempest itself. It has to do with the pole and the ground. And you might be getting 4 inches of rain that saturates the ground and the pole falls over. And so it's less about the device's ability to measure winds at that speed as it is your physical mounting apparatus. And so if you want it to survive a hurricane, overbuild it.
Got it. And then there's another question about, is there anything in the works to map lightning strike data?
Yes and no. I'm not sure if I have the exact answer and the exact, people want to know, what are you going to do and when is it going to be available? I don't have those answers. But as we get better and better at the geolocation of lightning strikes, it's obviously of particular value to the community of users to understand where those strikes are happening and when. And that's something we're highly aware of, and we're looking at how best to do that.
Great, thank you so much. I think, let's see, so we've got just a little over 5 minutes left. So if you have any last minute questions for Keith, please get them in now. There's one pretty specific one about the AI process. Is there a possibility for the AI to know that the next few days will be rain? And if the battery level on the Tempest is getting a little low, so it'd be better to charge things up.
Interesting. So as I mentioned, the AI and our analysis and improvement of the forecast is particularly focused in the 0 to 36 hour near term. Any meteorologists in the crowd know that the confidence level in the baseline regional forecast actually drops dramatically as you get past kind of that 48 hours out. People generally want to know, is it going to be sunny or cloudy or whatever out? But really the nuance is if you're providing very specific forecasting at the hourly level, we really focus on that 0 to 36 hour. And you're kind of kidding yourself if you're looking at an hourly forecast 10 days out. Warning, that's a guess at best. From a battery standpoint, there's some pretty sophisticated circuitry in the battery. Let's put it this way. The way it was designed is it was over-engineered from an electrical engineering standpoint. It takes about 5 hours of sunlight to power the LTO lithium titanate battery to power the device for about 28 days. If you happen to place the Tempest in a totally shady location, or you live in Antarctica, we also have an optional battery power boost pack that will add some power to the LTO battery when insufficient solar input is not available. But that's a great question. That would be an intelligent decision to see if there are sunny days coming. And we do have the ability to dynamically run the Tempest in a power save mode if the battery is starting to look low.
Great. Okay, let's see. One more here. How much does the vibration of the mounting pole influence the accuracy of wind speed and direction?
Oh, great question. So this is related to sighting. So vibration in the mounting pole actually affects two things. The one thing it affects the most, it affects the haptic rain sensor. So the haptic rain sensor is a very sensitive technology that feels the vibration signature of each raindrop. Therefore, things like a bird landing on it might cause a false rain signature. Vibration in the mounting might cause chronic false rain signatures. We've actually spent a ton of time analyzing and looking at things like birds landing on the device. We have a dynamic system that actually can identify and filter out and disqualify false rain from things like birds. In terms of vibration in the mounting, it is very important that you eliminate as many sources of vibration. We've done a statistical analysis over 20,000 devices out there, and we've found that this bird filtering and vibration in the mounting are the cause for any discrepancy in a rain calibration. And so if you can eliminate that vibration, it cancels out that chronic false rain and makes the rain calibration actually very amazing when you eliminate those two factors. I know the question was specifically about wind. The sonic anemometer is not meaningfully altered by vibrations in the pole mount. But in every case, we would encourage you to have the most stable pole mount.
Oh, that's fascinating. Yeah, I never thought of the birds impacting things so much, but.
You know, we do a few interesting things, like we have a light sensor on top of the device, and we can actually see the shadow from the bird when they dance on the top, and that's a pretty good indication that something's weird. And again, that's part of that data curation, qualification, and quality control that we have.
Amazing. All right, so we are just at the top of the hour now. So if you are an AMS Weatherband member, please come on over to the community and we can continue the conversation there. We look forward to more questions, and Weatherband members can watch the replay of this webinar on demand in the next day. So again, a huge thank you, Keith and David. We really appreciate you taking the time today to share all of this amazing knowledge and these great systems with us. And we really are excited to learn what our Weatherband members will be doing with it. So thank you again so very much.
Thank you guys, and thank everyone on here for your time and attention.
Great.
Hope you learned something.
Have a great rest of your day, everybody.
All right. Thank you.
Thank you, guys. Thanks, everybody. Bye-bye.
Hi. Thanks, David.